All right, for homework number 20, this is just more practice doing what we started in 19, so more antiderivatives. So number 5 says find the general solution of the differential equation and check the result by differentiation. So I left my check work up here. To be able to integrate here, I need to separate the dy and the dt. So it's going to be the integral of dy is equal to the integral of 9t squared dt. So I just multiplied that dt over here. When we integrate dy, we get y. And then on this side, we get 9 times t to the third divided by 3 plus c. And when I simplify that, 9 over 3 is 3, t to the third plus c. So the general solution to a differential equation is a function of y with respect to t for this one, if it's dy dt originally. So that's my solution. And I can check my work by going back and taking the derivative of both sides of this equation. And then I get dy dt equals 9t to the second. And that is what the problem started out as. For the next problem, we want to rewrite if necessary, integrate, and simplify. So I do want to rewrite this. I like to take the 1/2 out in front of the integral just so that it's not sort of in my way confusing things. And then instead of leaving this as 1 over x to the third, I'll rewrite it as x to the negative third dx because I want to use my exponent rules where I add 1 to the exponent. So when I integrate, I get 1/2. Add 1 to this exponent, you get x to the negative 2, and you divide by that new exponent. Then there's a plus c on the end. And then we just need to clean this up. This is negative 1/4, and the x to the negative 2 can get sent to the denominator. The plus c is just sort of along for the ride here, so that's the final answer. You're not putting the plus c inside of brackets and making it 1/2 or anything like that. Just like I did in the video for homework number 19, I left my checking my work off to the side here. So this says find the indefinite integral and check the result by differentiation. So I left the check here just because you're not going to be required to show that you're checking your work, I guess, on the AP test, but you will, it's good to be able to do that or to know the connection. Okay, so this is ready to integrate. So the integral of x to the 5th is x to the 6th over 6. The integral of 1 is going to be plus x, and then there's a plus c. And there's not really anything to do to simplify that, so that's my solution. And then if I want to check that answer, the relationship between these two things is I should be able to take the derivative of my antiderivative, and I get back to the integrand right here. All right, for the next one, you might want to rewrite this as the integral of x to the 2/3 dx. And then I'm going to use the power rule for integration on this. So if I add 1, if I add 3 over 3 to this exponent, I get x to the 5/3 divided by 5/3 plus c. And then we don't want to leave this complex fraction, so I can say that's the same as multiplying by 3/5. So 3/5 times x to the 5/3 plus c. You could also put the x to the 5/3 in the numerator with the 3. It's the same thing. Okay, and then number 30. For this one, you can't take the derivative, or we can't take the derivative of this right now because we don't have u substitution rules. And even if we did, we still wouldn't be able to do that. So what we're supposed to do with this is first square out this binomial. So this becomes 4t to the 4th minus 4t squared plus 1 dt. And then now that you have individual terms, now you can take the integral of each term. So this is going to be 4 times t to the 5th over 5 minus 4 times t to the 3rd over 3 plus t plus c. And there's really nothing to do to simplify this besides just make it, I don't need these parentheses here. So I'm just writing this down. So that's my antiderivative. And I can check my work by taking the derivative of the result I just got, and I should get back to the integrand. Okay, and then number 34, if it's just the integral of a constant, remember that's like having an x to the 14x to the 0. So you can take the integral of that. It's 14x plus c. And yeah, if we turn around and take the derivative, oops, not x, sorry, it's 14t plus c. It's t because this says dt, so it would have to be 14t plus c for the function. It can't be a function of x. All right, for the next section, same thing. Find the indefinite integral and check the results by differentiation. So for this problem, the integral of cosine x, I always have to kind of go backward in my head. I mean, of course you can memorize these, but I'm just thinking like, okay, what is cosine the derivative of? It's the derivative of sine. So this is positive 5 sine x. What is sine the derivative of? Negative cosine. So minus 4 cosine x plus c. And that's it. There's nothing to simplify there. You can double check, especially with your plus and minus signs. It's a good idea to check this. If you take the derivative of those terms you just got, you do get positive 5 cosine x, and then you get minus 4 times negative sine. So you do get the plus 4 that you need on the sine x. This is a function of theta, and it says d theta. So here I can say, okay, the integral of theta squared is going to be theta to the third over 3. Plus, you're thinking, what is secant squared the derivative of? Like, derivative of what equals secant squared? So that's tangent. So this is plus tangent theta. And then we say plus c. So that's the final answer for that one. And again, you can take the derivative of it and make sure you get back to the original integrand. For number 40, all right, I would like to, let's see, distribute this. So, because I can't just do the integral of secant times tangent minus secant. That's not something that we know. But this would become secant y tangent y minus secant squared y. All of that has a dy on it. So again, you're thinking the derivative of what with respect to y? The derivative of what gives me secant tangent? So this is what you're thinking every time. So yeah, what is that? That is secant y. And then what's derivative is secant squared? I think we just did this one, right? What derivative of what gives me secant squared? That's tangent, and it's minus because this says minus in front. So this is secant y minus tangent y plus c. All right, and if I take the derivative of that, I don't know if I stopped checking or if I erased my work or what, but let's just double check this. The derivative of secant is secant y tangent y. The derivative of tangent y is minus secant squared y. Derivative of plus c is plus 0. And we're supposed to get this. So if I factor out a secant y, I'm left with tangent y minus secant y. So yeah, that works as well. All right, for 49, we're going to find the equation of y given the derivative and the indicated point on the curve. So we have the derivative equation, 2x minus 1, and we have this point, 1, 1. So we want to find what is that specific parabola. That's the solution to this equation. So first thing I want to do is separate my variables. So make this dy equals 2x minus 1 times dx, and then I can integrate both sides. The integral of dy is y. The integral of 2x is 2x squared over 2. And the integral of minus 1 is minus x plus c. Okay, and remember, we have the point 1, 1. That's an x and a y coordinate. So I can clean this up a bit. But then I can also say that 1 is equal to 1 squared minus 1 plus c. So that just leaves me with 1 equals c. So find the equation of y. The equation for y is y equals x squared, simplifying that, minus x, and now I know that plus c is actually plus 1. So that is the equation for this parabola. All right, these are kind of interesting. Solve the differential equation. So they give you f double prime of x is equal to 2. So this is an equation. This is a function. And then f prime of 2 is 5 and f of 2 is 10. So these are evaluated points of the f prime graph and the f graph. This is an actual equation. So if f double prime is equal to 2, I want to remind you that the integral of f double prime of x dx is equal to f prime of x plus some c value. So if I integrate 2, which is the function, because it says f double prime of x, if I integrate 2 dx, I get 2x plus c. So that means that f prime of x is equal to 2x plus c. And then that's where this comes into play, because when it says solve the differential equation, we're trying to get f of x equals some equation. So now I know that f prime of 2 is equal to 5, so I'm going to plug that in. 5 is equal to 2 times 2 plus c. So that's 4, subtract, so c comes out to 1. So now I have an f prime of x equation. It's equal to 2x plus 1. All right, we're trying to get the f of x equation. So again, reminder, the integral of f prime of x dx is equal to f of x plus c, or maybe plus d or something. I guess I should probably use a different coefficient, but whatever, plus a constant. And so that means that I can integrate 2x plus 1. So if I do that, I get 2x squared over 2. So x squared plus x plus c. So that means that f of x is equal to x squared plus x plus c. And we were given in this problem that f of 2 is equal to 10. All right, so if I plug 2 in, if I set this equal to 10 and plug 2 in, I get 10 equals 4 plus 2 plus c. So this is 6. 10 minus 6 is 4 as a value of c. And finally, we get to f of x is equal to x squared plus x plus 4. That is the solution to this differential equation. All right, so same idea for number 64. So let's start off the same way. I'm given a function for the second derivative. So the integral of f double prime of x dx will equal f prime of x plus some constant. And so they're telling me that the integral, this is the integral of sine x dx. And remember, you're saying, okay, what sine is the derivative of what? So it would be negative cosine x plus c, right? Because the derivative of negative cosine x is negative sine, so positive sine x. So f prime x is equal to negative cosine x plus c. Now I'm going to use this. F prime of 0 is equal to 1. So that means I can say 1 equals negative cosine of 0 plus c. Cosine of 0 is 1. So 1 equals negative 1 plus c. That means c equals 2. So f prime of x equation is negative cosine x plus 2. All right, now we need to go backwards again. So the integral of f prime of x dx is equal to f of x plus some constant. So we want to integrate negative cosine x plus 2. All right, so the integral of negative cosine x is negative sine x. The integral of 2 is plus 2x plus some constant. So f of x is equal to negative sine x plus 2x plus some c value. And here's the last point. So because I know f of 0 equals 6, I can put in 6 for f of x and sub in a 0 for the x value. Sine of 0 is 0. 2 times 0 is 0. So c comes out to 6. So f of x is equal to negative sine x plus 2x plus 6. All right. Now, I maybe wrote a lot more than I needed to for those. Like, I really kind of spelled it out here, but I just thought this would be good to do so you can follow kind of the logic of everything. Okay, tree growth. An evergreen nursery usually sells a certain type of shrub after 6 years of growth and shaping. The growth rate during those 6 years is approximated by DHDT, where T is the time in years, H is the height in centimeters. The seedlings are 12 centimeters tall when planted. So because this says DHDT, that means that H of 0, I'm going to call the original function the height function, that's equal to 12. So find the height after t years. That just means find a function. What is the h of t equation? So for a, if I integrate dh dt, there we go. If I integrate dh dt, I'll be left with an h of t equation. So 1.5 t plus 5 dt. When I integrate that, let's see, 1.5 is 3 over 2. And then I'm going to get t squared over 2 plus 5t plus c. So I'm getting right now that h of t is equal to 3/4 t squared plus 5t plus c. And then we want to use the fact that h of 0 is 12. So I can put in a height of 12 and sub in 0 for the values of t. So that tells me that c is 12. So find the height after t years. H of t is equal to 3/4 t squared plus 5t plus 12. And then part B says, how tall are the shrubs when they're sold? So using the height function, because we're trying to find how tall, it says in the beginning of the problem, the shrub is sold after 6 years, and t is measured in years. So this is just asking me to find h of 6. Now h of 6 I can calculate. Got to open my little calculator here. See what it comes out to. It's got to think about opening for me. Okay, so when I plug in 6, that's 3/4 times 36 plus 30 plus 12. I could probably do this without a calculator, but whatever. So I got 69. So that's 69 centimeters for the height. So that's after 6 years. Okay. Is this? Yeah, okay. Last two problems. So this one is kind of like 64 and 65. It says use a of t as negative 9.8 meters per second as the acceleration due to gravity. Show that the height above the ground of an object thrown upward from a point s sub 0 meters above the ground with an initial velocity v of 0 is given by this function. So show why this function exists, and you're starting with a of t. So here are a couple of things to note that we don't normally write things like this. So we want to have some sort of v of t equation, right? We need a v of t equation, and what they're telling us is the initial velocity when you plug in 0 comes out to v sub 0. And the initial position, I guess instead of s, this function is called f. So f of 0 is equal to whatever that initial position is. Okay, so those are 2 points that I'm going to be using at some point. But for now, I want to integrate a of t dt, and that's going to give me v of t plus some constant. So I want to integrate negative 9.8 dt. That's equal to negative 9.8 t squared over 2 plus c. So that tells me that v of t is equal to negative 4.9 t squared plus c. And remember, we said v of 0 is equal to v sub 0. So v sub 0 is the velocity when I put in 0 for t. In other words, that constant, that plus c, it's v sub 0. So the v of t equation is negative 4.9 t squared plus whatever the initial velocity was. Okay, then we do this again. Now I want to integrate v of t with respect to time, because that will give me, they're calling the position function f, so that'll give me f of t plus some c value. And so I want to integrate negative 4.9 t squared plus v sub 0 with respect to t. When I do that, I get negative, oh, wait a minute. Sorry, guys. I jumped ahead of myself. There's no squared here. Yep, this is negative 9.8t. This is, that changes a little bit here. I got ahead of my formula here. Okay, sorry. Let's go back. Integrate negative 9.8. It's just negative 9.8t. That was silly of me. Okay, so negative 9.8t. And then when I plug in 0, I do still get that the plus c is the initial velocity. So v of t, this is better, is negative 9.8t plus initial velocity. Okay. Now, when I integrate that, I get f of t plus c. So I want to integrate negative 9.8t plus v sub 0 dt. So when you integrate negative 9.8t, here is where it's negative 9.8t squared over 2. And remember, v sub 0, initial velocity, is just some constant number. Sometimes it's 0, sometimes it's whatever, a number that's not 0. So that is going to be v sub 0 times t plus c. So that is f of t. So that's our negative 4.9 t squared plus initial velocity times time plus c. And then again, when we put in 0 time, we get s sub 0, the initial position that we launched from, whether that's the ground or height of a building, something like that. But you're putting in 0 for all of the times. So that means that c is the initial position. So therefore, f of t is equal to negative 4.9 t squared plus v sub 0 t plus s sub 0. So just put a little box like we're done. All right, and then the last problem is related to that, but not so abstract. So this says the Grand Canyon is 1,800 meters deep at its deepest point. A rock is dropped right there. Initial velocity is equal to 0 meters per second. A rock is dropped from the rim above this point. That means that the initial height is 1,800 meters. Let's assume the ground is the ground at the deepest point. So that's our 0. So S sub 0 is 1,800. Write the height of the rock as a function of time in seconds, and then how long will it take to hit the floor? So we are using the same position function and just kind of building into this. We don't actually need calculus, right? We just came up with a position function when you're measuring in meters and seconds. So I can just say, I think I called mine S of t because S sub 0, that made sense to me, but you could call it f of t if you want. But it's negative 4.9 t squared plus 0t plus 1,800. So what is the position function? It's just negative 4.9 t squared plus 1,800. So I did not need calculus to do that because I did calculus before to kind of show why that equation's true. And then find how long will it take the rock to hit the canyon floor. So that's when the position is 0 from 1,800 meters up. Okay, so we can solve this for t squared, right? I can say subtract 1,800, divide by negative 4.9. So this is what t squared is equal to. You don't want to round this. You want to square root that answer. And now I can round 19.166. So t is about equal to 19.166, and time is measured in seconds. So on this problem, no calculus was needed. No, I guess I should say no calculus. Usually I say calc, meaning calculator. So no calculus needed. We can solve that just with our Algebra 2 skills. All right, that finishes this video. Please come into office hours if you're having questions on any of this stuff.